Hello. Now we're going to turn to a regression model. A regression model is we're going to perform significance tests on data that shows a linear relationship between the two variables. Now, we studied a whole chapter of regression model stuff, and that was chapter 2. And we're going to review a little bit and then show you a little bit more as we use significance tests. First, here's a study that showed intensity of crying and eventual IQ of babies. So they went and rated little babies on the scale of, I don't know what it was, and then they eventually checked out their IQ, and they wanted to see if there was a relationship between crying and intelligence. And you could put all that in your L1 and L2 and do your regression, but they did a regression analysis for us, and I'm just going to give you a little reminder of what this is. So across from constant is your y-intercept, and across from the variable cry count is going to be your slope. As we move down here, this s, this is the standard deviation of the residuals. Over here is your standard error of slope. Now this top part we don't use, but these bottom parts we're going to use. So if we're looking at our slope, this is our standard error of our slope. This is our t-statistic for our slope, and this is our p-value. And I'll explain this more as we get into the test. But all of those are the values associated with the slope. So if I say find the least squares regression line and interpret, what we're going to do is look back at this data, and this is our line. So IQ equals 91.3 plus 1.49 cry count. Now this interpreting is mostly just so we remember what we learned in chapter 2. So I'll type this out. Cry count, or so 91.3 means that if cry count is 0, then IQ is 91.3. That's what 91.3 means. That's the y-intercept. The slope means for every increase in 1 unit of cry count, the IQ goes up 1.49 units. So that's pretty interesting. We see that as kids cry more, their intelligence increases. All right, we'll do more with that in a bit. Find the R value. Now this doesn't give us our R value, but it does give us our R squared. So our R squared, which is our next question, is 20.7. So if R squared equals 0.207, we have to square root that to get it up here. So I'm just going to take the square root of 0.207, and I get an R value of 0.45. Now you always have to look at the slope to see if that's a positive or a negative value. And since this is positive, our R is going to be positive. So here, if we want to interpret this, so we have a weak linear, or I should put the word positive in there. Doesn't make sense to put it at the end for some reason. Positive, weak, linear relationship between cry count and IQ. So there's a relationship. It's not a super positive one, but it exists. And remember, when we're interpreting an R value, we want to talk about the direction, the strength, and the form uh, to get those. Now, our squared value would say 20.7% of the variation in our y variable, which is IQ, can be explained by a linear regression with cry count. That's how we explain that. The variation in y that can be explained with a linear regression with x. All right, now we have another one. Now, in that equation, I'll change the screen. A and B are statistics. That means if you take another sample, you're going to get a different slope, and you're also going to get a different y-intercept. So you can think of it like this. For each value of x, there's going to be a normal distribution of values, where the center is going to be on that estimated line. And same with over here. So there is a theoretical value, we call it alpha plus beta x, where alpha is the true y-intercept. If you took an, every value in the population, that's going to be the y-intercept. If you take every possible point and put it on there uh, and calculate the slope, that'll be your beta. And so we can write an equation like this. Typically, we can't find every data point in a population, so we just have to use a sample A plus BX. Now, here's another couple review things. Our first point of the data is 1087. What is our predicted value for y if x is 10? So what we have to do is we have to look back at our equation. Hopefully I can read my own writing in a couple pages. And throw that down. And that's our equation. If I plug in 10 for cry count, then 10 times 1.49 equals 14.9 added to 91.3. So our estimated value, our y hat, is going to be 106.2. That's what we would estimate to be. However, we got a value that was much below that. So our residual for that point is, we take 106.2 minus 87. So our residual equals 19.2. Now, two other things that we need to interpret is our standard error of residuals and our standard error for slope. Now, our standard error for slope means the amount that we expect the mean to change on repeated samples. So if you take another sample, the same sample size, we would expect the mean to deviate. Now, not all the means are going to be exactly the same. We're just taking sample means. So not every slope is going to be the same, but we would expect them to be similar. And the amount we would expect them to deviate is about 0.487. Now the ask tells us how far we expect a point to be away from our regression line. So this is the amount that we expect a typical point, maybe I should say the distance, sorry, that we expect a typical point to be from the regression line. So it's that vertical distance from our regression line to the actual point. So if I look at this residual, that's 19.2. There's going to be other points that are closer to the line than that one, but because a typical one is 17.5.